So, we are on learning target 3. We know how to find the zeros. We know what the zeros of a parabola are, right? Okay. We know that they don't always have zeros if they don't touch the x-axis. We know how to get the graph of it on the equation or on the graph when it's in standard form. We know what the vertex is. And now we're going to 3 and 4 are kind of the same one. This says I'm just going to describe all the transformations of a parabola and what it can do, right? And if you remember from bell work, transformations are reflections, slides, right? Like a translation is when you slide it. And then we're going to talk about, we're not going to graph it today. Today we're just going to talk about what happens to the shape and where it's at. And then tomorrow we're going to graph it. So, in order for you to understand this part of it, so hold on to your calculators, we'll get to that in 5 minutes. I want you to know that there are 4 different transformations. So there are 4 different transformations, okay? So, the first one that we're always going to talk about is, we're going to call it a reflection. So one of the first things we can do with a parent function of a parabola is reflect it, okay? So if you think about what the parent function of a quadratic equation looks like, remember, your vertex is always at 0, 0 for the parent function, and then you have your 1 up and your 1 over, almost kind of forms like a little eyes and nose, right? And then it's not a straight line, it's a curved line, right? So this is your parent function, right? And this is y equals x squared. And so everything we're going to do today is going to be comparing what we're doing to the parent function. So if I were to say, take this parabola and reflect it over the y-axis, meaning it kind of already is reflected over the y-axis, right? It's a mirror image. The y-axis right now is serving as the line of symmetry. So to get it to actually flip upside down, like this, that is actually a reflection over which axis? The x-axis. So when we talk about reflecting, we're going to reflect it over the x-axis, not the y-axis. Okay? And did we talk about how that? I think we did in our notes. What can you put in front of the y equals x squared to get it to reflect? Same thing that you did when you try to get a straight line to reflect. A negative, right? Okay, so right now I'm just telling you what they are, and then we're going to see what they actually look like. So that's the first thing that a parabola can do. The second thing that a parabola can do is, we're going to call it a vertical translation. So the question there is, vertical means the up and down, and translation is just a fancy word for shifting. They also call it a slide, right? Remember when we did bell work and I said, take this figure and slide it? So we're going to be able to take this parabola and say, okay, let's move it up. It's all about where the vertex is. Okay, we're going to learn what controls that. If I can move a parabola up and down, I can also move it left and right. But that's not called a vertical translation. That's called a, horizontal translation. Okay? So the horizontal translation is the left or right shifting or sliding. Okay? Slow down a minute. Let you catch up. And then there's one more thing that we can do to our basic quadratic equation. We can flip it upside down. We can move it left and right. We can move it up and down. And I do want to address this. Somebody said, well, you can move it diagonally. And that's not really a transformation, because in order to move, like in other words, if I wanted to take this parabola right here and just shift it like diagonally from the vertex being here to here. There's not a diagonal shift. A diagonal shift is actually made up of a horizontal followed by a vertical. Do you know what I mean? Or a vertical followed by a horizontal. So in order to get it to move diagonally like that, it's a combination of two shifts, a horizontal and then a vertical. So there's no diagonal. The last thing we can do with it is actually change the size of it. We can make it wider or we can make it narrower, okay? And we're going to call that changing the width. Okay? So we can make it wider or we can make it more narrow. Okay, but wide and narrow are not fancy high school algebra for an 8th grade class word, right? We need a better word for wider. We need a better word for narrower. And yeah. So if it's getting wider, we're going to say we're taking that parabola and stretching it. So we're going to call that a stretch. Okay? Picture just like literally pulling the sides of it out. Okay? And to make it narrower, picture just taking it and pushing it. So we're going to call that a compression. Okay? So those are the 4 transformations that we can do with a parabola. And then we're going to take a look at how to do that. So, get your calculators out and turn them on. Okay, so we're going to talk about a function that you may or may not have used or know how to use. But when I used to teach advanced 7th graders for the first time slope intercept form, y equals mx plus b, this is how I taught it. So go to y equals. We're going to use these buttons at the top. Okay, if there's anything typed in your y equals, which I'm sure there is, use this little scroll button to scroll down and hit clear. Scroll down and hit clear. So just clear everything out right now. So there's nothing there, okay? The next thing to think about is we're going to talk about a window. So if you look at this window right here, hit that button, all right? That means, actually hit the graph. Hit the word graph right here first. So this is your standard window. This is a -10, +10, -10, +10. If you ever need to adjust that, kind of like Google Earth, right? Where if you want to zoom in, my daughter, when she works, she travels. So, like yesterday, I want to know what time to have dinner ready. So I'll go on, find my friends. Do you know that? And, like, this is where she was yesterday. So this was, like, Michigan. So this is, like, all the way, like, right over here. So I'm like, and this was, like, at 4 o'clock. I'm like, okay, she's not going to be home for dinner. So what I do then is, you know how you do that with your screen? You zoom it out. So I want you to picture, like, a zoom right here. So let's say I want to zoom in on quadrant 1 right now. Okay? So if I want to zoom in on quadrant 1, hit window, and you see all these things, ignore the stuff at the bottom. See how it says X min, X max, Y min, Y max. Those are the only 4 I'm really concerned with. The scale means do you want to go by 1s, 5s, 10s, whatever. So on this graph, which one, north, south, west, or east, do you think is the X min? Min means minimum. Minimum means the lowest. So which point is my X min? This is my X axis, and this is the minimum it goes. This is the X max. So where's your Y min? North or south? South, and this is your Y max. So if I kind of want to zoom in, of course, have you ever found yourself, it's funny because I found myself doing this like many times before on my calculator screen. I'm like, okay, it's a calculator, not an iPhone. So you have to do it manually, heaven forbid. So go into window, and if I want to zoom in on quadrant 1, I'm going to change my X min. I'm going to change it to -1 instead of 0. You'll see why. And then I'm going to change my Y min also to -1. Then I'm going to hit graph. I made it like that because I like to see the origin. If you change your min to X to 0 and your Y min to 0, I mean, it still gets you what you need to. But do you see what I mean? You kind of lose the axes, don't you? So that's just a kind of a nice way to play around with the windows, okay? If you want to get back to your standard window, hit zoom. And zoom 6 is your standard. So you just hit zoom 6 and look what happens. It takes you right back to zooming out. All right? So that's a little bit about the window, okay? So now go back to y equals. And when I taught y equals mx plus b, so right now you're just watching, we are going to do some exploration on the calculator, but when I taught y equals x, I said, okay, advanced 7th graders, here's the deal. This is called the parent function. Y equals x is a straight line. It goes through the origin, and it looks like this. And then I said, how can we change this line around? And then I went in and I had them type in y equals x plus 4. And then they saw that it took that line and it moved it up. Okay, I got to change my color because I want that to be blue. Oh, that's magenta. Woo. Okay, because we're comparing everything to that red line. The red line is the parent function. So then I wanted them to see that putting a plus 4 after it just shifted it up 4. And then I asked them, you know, what would you type in if you wanted it to shift down 3? And they made that connection that, oh, if you put a minus 3, then it shifts it down 3. Great. Okay, remember? Okay, so I don't know if you learned it this way. So then there were all kinds of things we did. I said, okay, what would happen if you reflect that line, if you put a negative in front of the x? So you have your y equals positive 1x here, and putting a negative in front shifted it, like reflected it, right? Over the x-axis. So this is the same process we're going to go through except learning about a parabola. So in your y equals, clear out anything that's there. And in your y1, I'm going to actually change that to blue. It's easier to see. In your y1, I want you to type in y equals x squared. And your x button is, I want to clear that, right here next to the green. And the squared button, you know, is down there. So y equals x squared. And then hit graph. Graph is all the way on the right, top right. So right now, all I want you to do is have your parabola set. Good? So that's y equals x squared. So we're going to do some predicting. So don't hit graph until I say, okay, graph it. So go back to y equals. Scroll down to y2. Yours don't have fancy colors, but still will get the same effect. Type in your y equals x squared, and then don't hit graph. Hit a plus 3 after it, but don't hit graph. What do you think adding a plus 3 after your x squared is going to do to that parabola? What did it do to the line? It went up 3. Okay? So if I took this blue line and scooched it down 1, 2, 3, it would fall right on top of that red line. Okay, so basically I didn't change the shape of it or the size of it. I changed its location. I did a vertical translation. I slid it or shifted it up 3. So what I want you to really look at is putting a number after the x squared controls the vertical movement. So we're going to do these games here where I'm going to pull my calculator aside and I'm going to type something in it and then you need to match it. So you don't know what I typed in to get it to go there, but I need you to type in what you think and then I'm going to say show me your screen. So as soon as you have that, I want you to show me your screen and so that way I know you're with me. So what would you have to type in to get? Good.
Oh, show you what we typed in?
Nope, show me your screen. Just show me your shape. Yep. Good. Good. Okay, obviously this is like the easiest one, right? Yeah. So in order to get it to move up, we put a plus 3. In order to get it to move down, we put a minus. So this is right at the origin because there's nothing after it. It stays at 0. This moved it up 3. This moved it down 4. Pretty easy, right? Okay, so go back and clear these out and type what you think you need to type in order for it to get, there's your parent function. We're always going to keep that one in our number 1. What would you need to put in number 2 to get its reflection? Hold your screens up when you have it. Does it look crooked? So hold your screens up when you have it. Good. Good. Okay, good, AJ. Yeah. Okay, and what did you type in? Yeah, you just typed in a negative, right? So you took a negative and you put it in front of the coefficient, because remember the coefficient is 1. That's going to be really important later. Okay, so far we've taken care of the first two translations. We know what reflects it. We know what shifts it up and down. We still got to talk about moving it left and right and changing the width. So are you with me? Actually, let's do a combination of this. Try to get, try to match this one. So if this is your parent function.
How do you get it back like? Okay. Okay, we move it back.
So yeah, try to do that. Yeah, it's like a Zoom 6. There we go.
Thank you.
Yeah. So try to make that little. It looks like a football, doesn't it?
Yeah.
With the grid lines. So what are you going to type in your input screen to get that? And when you have it, hold it up. Very good. Good. Yep. So you can clear out your Y3 for it now.
Oh, I got it.
Good. Okay. So I combined 1 and 2. Not only did you put a negative in front, you also put a what to get it to shift up? Plus 5 or whatever it was. 1, 2, 3, 4, 5. Okay. So everybody has it. So there's my red parent function. There's my negative that flips it. There's my plus 5. Okay, you're ready for number 2. All right. So clear out number 2. And this is very important. Don't hit graph until I tell you, because we're going to make a prediction. Okay, I want you to type in an open parentheses. An open parentheses is the one above the 8. And the closed parenthesis is above the 9. So then I want you to say, instead of taking x and square it, I'm going to take x, I'm going to add something to it, then I'm going to square it. Don't hit graph yet. So at first, you're taking the x and then squaring it, and then we put a number after it. Here I'm taking the x, and before I square it, adding 3 to it. So if x is 5, I don't want to square 5 and get 25. I want to square 28 or square 8, right? Because 5 plus 3. So where do you think this is going to move it? It's not up or down, because we know that it's the number after that moves it up or down. It's going to be our left and right. Where do you think this is going to go? Okay, hit graph and see. It's the total opposite of where you expected it to go. So let's talk about that for a minute. You actually know why this is the case, because you just took a test on it yesterday. Let's go back and look. I have x plus 3 squared. So right here, what that means, if I have y equals x plus 3 squared, that's the same as x plus 3 times x plus 3. And what are the zeros? What's the 0 of an x plus 3? Negative 3. So you're looking at a big old plus 3. In common sense of what everything you've been taught tells you, shift it to the right 3, because that's what up 3 meant, right? So this did the opposite of what you thought it was going to do. And here's why. Because it's the 0 it's telling you to go to, not to go to the plus 3. So if I want to get this shape, what would I type in? So go ahead and type it in and show me your screen. So your parent function is the one in the middle. Putting a plus shifted it to the left. Very good. So putting a what will shift it to the right. Good. Yeah. Mm-hmm. Yep.
Oh, wow, I did it.
Good. Good. Okay. So obviously, you kind of picked up on it, that it did the opposite of what you did. So if you wanted to shift to the right, you had to put in a minus. To the left, you got to put in a plus, and that's so backwards from what we're used to.
And it's always going to be the opposite. Like
For the horizontal shift, it is.
Okay.
But was it the opposite for the vertical? No. A plus did mean go up. So you really have to keep these 4 things straight. Okay, so clear out that and that. And then I want you to try to get this. Yeah, but it's just to graph it, which, all right. Let's see if you can put it all together. That's my y equals x squared parent function. Remember, I said there are no such things as diagonal translations. Diagonal translations are made up of horizontal translation followed by a vertical. So you have to put the 2 things together that we just did separately. Garrett, you got it. Good. So it shifted over 4 and down 2. So manipulate that equation to get it to shift over 4 and down 2. You want it dipping just below that x-axis. Put the 2 separate. Very good. Put them together. Good. Is it shifted down? Yeah. Okay, and here's the awesome part about this, in learning it this way. If you type something in and hit graph, and oh shoot, that's not where you were expecting it to go, then you hit y equals and you change it. And then you hit graph again. And you see what you really are manipulating it and getting to see what changes affect what. Got it? Not yet? So the number, I'll give you hints. The number inside the parenthesis controls the horizontal. The number outside and after controls the vertical. The horizontal does the opposite of what you would think. The vertical does exactly what you would think. All right. Are you ready to look and see what I have typed? So, in order to get that to shift 4 to the left, I had to have put in an x plus 4. And then in order for it to shift down 2, I put a minus 2. So is
that, and it said error.
Okay, because I think that, okay. Now, whenever it says error, see the number 2 option, it gives you a go-to. Scroll down and hit go-to, and it'll highlight what your error is. Like, you'll get that a lot when people use the negative sign instead of a minus sign. So that might happen. Okay, so are we good? Are you ready for this one? Clear out number 2. Now, this one's going to be a little trickier. All right. Woo! This is so. Oh. Match it. If you match it, I will be so happy. All right. It's all about where the vertex is. So I'm going to zoom in so you can do a little counting. It's 1, 2, 3, 4, 3, right? So it's 3 to the right, and follow it over 1, 2, 3, 4, 5. So it's 3 to the right and 5 up.
Are you joking?
Nope. I think I didn't get it.
3 to the right and 5 up.
Awesome.
No. Oh, and it's reflected. Good. Okay. It's all about the placement of the negative, right?
Yeah.
Where should the negative go? I did it. The only thing that can be inside your parentheses, good, is the x and the plus or minus.
I did that.
So change what you need to change to get it.
Oh, I get it now.
Yeah.
I get what it is.
Okay, I heard somebody say, I got it, but it's not down, it's up. So, what one little button can you you need a negative somewhere. So figure out where you're going to put that negative. Okay. That negative, look where it's at. It's on the outside of the parenthesis. Minus 3 shifted it to the right. Plus 5 shifted it up. Got it? Okay. So now, let's do it backwards. Tell me what this is going to do. Because this is what your homework is going to be like.
Oh, no.
Don't hit graph. Tell me, before I hit enter, where is it going to go? It's not going to reflect. It's going to shift 5 to the what? Left and 1 down. And by it, I mean your vertex. Right? It's going to go from 0, 0, and it's going to go 5 to the left and 1 down. Right? And it did not flip. If I needed it to flip, then I would go back in here. I would hit insert, a negative, and then it would flip upside down. Okay? All right, so that's 3 of the 4 transformations. We got to talk about this next one. So this would, yeah, wider and narrower. And we kind of alluded to this a little bit. Go back in, hit y equals. Hit clear for 2, hit clear for 3. Make sure you keep your x squared. All right. So we have y equals x squared. Let's see what y equals and 2x squared would be. This is what we played around with a little bit. Oops. 2x squared. And it does what?
Oh no, it's going to make it narrow.
Yes. So we expect y equals, 2x squared. What? It actually made it narrower. We're going to talk about y in a minute. So let's make it 5x squared. See what that does. Play around a little bit with it. Play around with 10x squared and 20x squared and see what it does. They get pretty narrow.
Yeah, I'm gonna put 100.
Yeah, see what it does. Probably only almost looks like a vertical line, so tight. Okay?
Oh my God, it's just like a screw.
Yeah. So what we are learning, listen, I know you're playing around, but I really want you to listen. When we make the coefficient in front of the x greater than 1, because you know the coefficient there is 1, right? Mm-hmm. When we make it greater than 1, it does the opposite of what we expect it to do. Kind of like the horizontal translation did, the opposite, right? So here's really important. Are you listening? Of the 4 translations, 2 of them do the opposite of what you would expect, and 2 of them do exactly what you would expect. That's a really good way to remember that. So here's the hard part now. Everybody thinks that if you make it 2, 3, 4, 5, and 6, it gets narrower. That's right. What makes it wider then? No, a negative reflects it. Yes. So what kind of numbers are less than 1 but aren't negatives? All those rational numbers on a number line in between 0 and 1, and they're called proper fractions. They're in between 0 and 1, and there's an infinite number of them, right? So 1/3, 1/2, 2/5. Play around with that. So let's take just 1/2, and to do the half, you know you hit the divided by x squared. And this is going to do exactly what you expect it to do. That is my regular width right there with no whoops. Okay, this is good because I was typing so fast. You want to know why it's a straight line? Yes, because if it's not a second degree, it's not that shape. This is linear. Somebody said that before and said, well, mine isn't, mine's a straight line. I knew immediately that they forgot to put the squared because linear is that. So there's y equals x squared, and here's y equals 1/2 x squared. It got wider. Play around. Put y equals 1/5. Put y equals 1/50th. Yeah. Whoa. That's 1/50th. So here's where a Google Earth zoom out would be pretty helpful. Because I'm only at 10, -10, right? So if I zoomed out, I would eventually start to see the shape of it, but it would be like a big giant one that would speak in slow motion with that voice, right? Right? So are you kind of starting to see what this does? Okay, so are you ready for like the ultimate? We're going to put all 4 of these together. Okay? Actually, I'll give you one practice round. Here's a practice round. Ready? I'm going to take a -4 and then x minus 2, square it, and add 3. Okay, don't do anything yet. Let's look at this. That negative is going to mean it reflects. It's going to be opening downwards. That 4 means it's going to get what? Wider or narrower? Stretch or compress? It's going to compress because stretch means bigger, but it does the opposite. This is going to make it shift 2 to the right, and then this is going to shift 3 up. So here is my parent function. So I'm going to expect it. I forgot what I typed, but it's going to be somewhere. Yeah. So it got skinnier, obviously, so it's a compression. It flipped upside down. It shifted 2 to the right and 3 up. Are you ready to try one now? Okay. So I got to pull this aside, and you have got to try. Oh boy, if you get this, I will be so happy. Okay, are you ready? We got pirate bucks on the line. If you can get this to match. Okay, so here's the deal. I will kind of help you out with the vertex a little bit. It looks like it's shifted 1, 2, 3, 4 to the left, and follow it over to 2. And it looks, does it look a little wider? Yeah, it looks a little wider. All right, I got a pirate buck ready for whoever can get it to match. Are you shouting at your calculator?
I need the fraction, that's right.
Insert is second, and then the INS above the delete. Yeah, it's hard because if you have a big long thing written, you don't have to clear it all out. There's an insert button.
Did I get it?
Yeah, that looks good. Woo-hoo!
Wait, how many is it?
It's 4 to the left and 2 down. I'm not going to be picky about the corrections. That's good. I mean, it's so, yeah, good.
I think I got it.
All right. Okay. Woo.
I'm not even
You gotta keep playing until you get it.
I'm done. No, we're close.
This is the ultimate, like all 4.
It keeps on just getting skinnier and skinnier.
Okay, if it keeps on getting skinnier and skinnier, then stop making the numbers 4, 5, 6, 7, 8. What makes it get wider?
3, 2, 1.
No, it's the opposite of what you would think. The bigger number doesn't make it bigger. A fraction makes it bigger. A whole number makes it smaller. So if you already got your pirate buck, go ahead and maybe help somebody sitting by you.
You're nutsy.
Playing.
Wrong way. Okay. 1 divided by 6.
Okay, how do you make it flip all the way?
It's got a negative in front of your fraction.
Okay, so I got 0.
Dang, now I got it. You know that?
I got it right. I got rid of it. Yeah, so you got to do negative. No, you got to do positive.
Okay.
That doesn't help.
All right. We need it upside down. There. We need it to get wider. I used that. The key was to put the fraction and the reflection on the outside of the parenthesis. The only thing that can be on the inside of your parenthesis is your x and either your plus or your minus. And because this shifted to the left, my 0 is -4, which would mean that it would have been a +4 in the parenthesis, right? Don't forget your squared, or it's going to be a straight line like mine was that one time. And it shifted down 2. And all of that is, actually I used the third 1/4. It's hard to tell when like that. Okay? Does everybody understand? Yeah.